Good day, everyone. I'm from Group 2 of Section 30. My name is Anson Ho Chiu Sang, and my groupmates are Li Junqing, Tan Yao Yi, and Tommy Lau Pei Wu. The assignment topic we given is Dataset B. For Part A, we need to analyze the data. First, we divide the data into three main parts, which are morning, evening, and night. Then, we calculate the sample mean, sample variance, and sample deviation for each set of data. So all the data is put in the table. From the result, the comparison graph is plotted for each category of dataset of different shift. So here is a tree graph. From the total sample size given for each shift, the frequency for morning shift is 73, evening is 66, and night is 61. The weight of table produced by different shifts show the greatest variance, especially evening shift, because it is higher variance compared to relative density and tensile strength. Higher variance means there is larger difference in the quality of table produced. Tensile strength produced by different shifts show approximately same variance between the three shifts and the smallest variance compared with relative density and weight.
Hi, and a good day to Doctor. Today I will present for Part B, Units of Fit test. In our case, this test is used to test whether the weight of pure Rajat Urabi is normally distributed with a 350 ng with a standard deviations of 15 ng. First, we need to define our null hypothesis H0. B. The weight follow the normal distribution with a mean of 350 ng and the standard deviations of the 14 ng. While the alternative hypothesis H1b, the weights do not follow the normal distribution with a mean of 350 ng and the standard deviations of the 14 ng. Then, we also assume the significance level alpha to be 0.05. Then, by using Microsoft Excel, we can determine the minimum value and maximum value of the weight. Then, we can construct a suitable group intervals to construct a frequency distribution. Then we start to comparing the observed frequency and the expected frequency by calculating the square of the difference of the observed frequency with the expected frequency, and then divided by the expected frequency. And each of the value is summed up to obtain the test statistics. In our case, the value of the test statistics is 2.547. And please be note that our probability is calculated by applying this formula and obtain the value from the statistics table. And our frequency, expected frequency, is calculating by multiplying the total number with the probability. Since significance level alpha is equal to 0.05 and the degrees of freedom is obtained as 3, then we should reject H0 if the test statistics is greater than 7.147. Since our test statistics is obtained as 2.547, which is smaller than 7.147, then there is no significant evidence to reject H0. Therefore, in conclusion, there is no significant evidence that the Raja Lagu tables produced in the December 2020 does not follow the normal distribution with a mean of 350 mg and the standard deviations of the 14 mg.
Hello guys, I'm Tommy Lau. Now I would like to present the part C where we need to determine whether there is a significant difference between the table's weights for all the different shifts. For this condition, we use the homogeneity test. We assume the null hypothesis as the table's weights are same for all the different shifts, while for the alternative hypothesis, we let it as the table's weights are not the same for all the different shifts. Then we record all the observed frequency according to the different weight range and the three different shifts. As a result, we will get the table like this. Then we calculate the total frequency for each row and each column. To find the expected frequency, we will multiply the row frequency and the column frequency, then we divide it by the total frequency of the data. Then we will get a table like this. Next, we minus the observed frequency with the expected frequency. We square it and divide it by the expected frequency, and we will get a result like this for each of the observed frequencies. We sum them out, and we will get the test statistic, which is equal to 16.2899. And here we assume 5% significant level, where alpha equal to 0.05. We calculate the degree of freedom, which is equal to the number of row minus 1 multiply with the number of column minus 1, and we will get 6. And here we can find out the critical value, which is 12.5916. For the decision, we will reject first node if the test statistic will greater than the 12.5916. As we can see, for the test statistic, which is 16.2899, is greater than the critical value, we have enough evidence to reject first node. And here we can conclude that the tempered weights are not the same for all the different shifts. And we can say also there is a significant difference between the tempered weights for all the different shifts.
The part C, I will be taking over the part D. In part D, I need to derive a regression model based on study, estimate the tensor strength based on regression model, and lastly verify the regression model. So first, from the studies, it indicated the tensor strength depend on the relative density. From this statement alone, we can conclude that the observed quantity y equate to tensor strength, and the manipulated quantity x will be the relative densities. So we can model a very simple regression model, y equal alpha plus beta x. So from the previous data collected, we can generate this data, y average, x average from the part A part where we calculate the means, while sxx, sy, and syy will be calculated manually using a formula. And this is the value that we achieve. And from this value alone, we can get beta and alpha. Beta equal to 0.083 and alpha equal to negative 1.72. And from these two values, we can model our regression linear model, which is negative 0.172 plus 0.083x. So next is we want to do an estimation on tensor strength based on available data. So for the relative density 60x 74.3 and 80.1 will result in estimated tensor strength by substituting their relative density into the previous formula, y equal negative 0.172 plus 0.083x. Nextly is we want to verify this model, and to do that, we need a null hypothesis which is H naught beta equal 0, and the alternative hypothesis of beta more than 0. So the next thing is we need to determine the t statistic, which in this case is negative 0.51 for the intercept. The intercept will be equate as alpha, and the x variable 1 will be beta. So we want to focus more on beta since we want to determine whether that there is a correlation between both these value. So it's 21.84, and this will be the upper and lower limits for 95% for 0.01 percentile. So since t-test 21.8497 is more than t-critical 0.09 from the previous part, so there's sufficient evidence to reject null hypothesis. We agree with the study that there's a correlation between the relative density and the tensor strength. Thank you for listening for our presentation.